We're going to go over all the graphs you need to know for AP Micro. You will notice probably that these aren't really that tough. That's kind of the point. They're not supposed to be really tough. It's very simplified. However, you need to understand the concepts behind them. You have to understand, oh, why is this graph so weird? Why is this graph all over the place? What is going on this graph? You need to understand the reasoning behind these graphs to truly understand AP Micro at least. So it all begins with the production possibilities curve. The production possibilities curve, or called the frontier at sometimes, shows the relationship between two products and how much we can produce of those products. So here we should see wine and apples. Let's say we're at this point right here. This could be, let's say, 10 wine and 0 apples. That means we're producing 10 wines and 0 apples overall. Or we're at this point. We could say this is 8 apples, 0 wine. You can see that there's two different combinations here. We can produce all wine or all apples, but we can go into the middle almost. B, let's say B is 5 wine, 5 apples. It's a combination in the middle between apples and wine. A, slightly more wine, let's say 6 wine, 4 apples. C, it could be 6 apples, 4 wine. You get what I mean here? These show in between apples and wine. Then let's understand D and F. D is inefficient. Why? Because let's say this is 3 apples and 2 wine. Well, you can already see here, we could produce more wine or we could produce more apples. Because it's inside the graph, it shows that we can graph more of both apples and wine. So that's really important. F is simply impossible. This is a point we cannot reach on the graph, at least yet. Let's say this could be 10 apples and 10 wine. Currently, there's no point on the graph that can produce 10 apples and 10 wine, so F is just impossible. Now, what we saw here was a concave graph. If it's curvy like this, that means that the two products are unrelated. So here's apples and wine. That's because there's a increasing opportunity cost. However, you can also see a linear PPC, something like this. If the two products are related, so here are cakes and cookies, or let's say t-shirts and hoodies, then it's a linear graph because it's a constant opportunity cost. So just make sure you know if two products are related, you have a linear PPC. If two products are different, you have a concave or curvy PPC. Now, the curve can shift outwards if economic growth, innovation, or productivity go up, because then you can produce more goods. Let's say there's more bakeries or more better baking equipment, I don't know. Then we can produce more cookies, so that goes up, and then we can also produce more cakes. Then let's say here we can pick more apples, or we have better apple picking technology. That doesn't really increase the production of wine. So the graph is just going to expand over here because we can produce more apples, but we can't produce more wine. So now let's practice a little bit. Pause the video and answer these two questions. Now that you've hopefully answered both questions, let's look at number 5 first. We have a PPC here, corn and robots, and it's increasing to the right. Which of the following events could have caused this shift into PPC? This is a very, very commonly missed question because they see, oh, it's increasing. That means we see some sort of economic growth. A, that's very easy. But they're not looking at it and understanding it properly. We're seeing here that corn is increasing. We're producing more corn, but we're not producing more robots. That's the key here. So if we were to increase economic growth, we would be producing more robots. So A, it simply cannot be A. So the answer is actually B, better farming equipment, because we can produce more corn, but we can't really produce more robots. C wouldn't make sense, because if you decrease productivity, it would go inwards. An increase in the demand for corn, that doesn't increase anything on this graph. An improvement in robots, that doesn't increase corn, that improves robots. So here you would have B. Now you have number 3. Based on the comparison of X, Y, and Z, the opportunity cost of an additional consumer good is... You should have gotten C here. You have to look consumer good, and you're seeing that consumer goods are decreasing really rapidly over here. They're not decreasing that much over here, but they're decreasing a lot over here. So X actually has the lowest opportunity cost. Y has a medium opportunity cost, and then Z is the highest opportunity cost because it's decreasing the most. So make sure you note of that. Then one final question. Pause the video and answer this question. So now that you've hopefully answered number 4, you can notice this isn't a traditional PPC. This is basically a chart. It's showing you different plot points. It is basically making you understand what's going on. There are some questions occasionally kind of like this on AP macro exam, where they're going to give you charts or tables instead of actual graph. Based on a comparison of points A, B, C, D, and E, the opportunity cost of an additional robot at point D is, and you should have gotten 10. For opportunity cost, we look at the next unit. So for point E, we can see we're producing 0 pizzas and 4 robots. At point D, we're producing 10 pizzas, 3 robots. So the opportunity cost of an additional robot when we're increasing 1 robot is 10 pizzas because we're losing 10 pizzas. So the answer here is D. Now let's talk about supply and demand, the essence of AP Econ. You should understand this upward sloping line is supply. There's many different reasons why, but it's basically because of different laws and effects. Basically, suppliers want to pay more for goods, want to pay more for produce more for goods if it's more expensive. Then demand, there's 3 main reasons that demand is downward sloping. You don't need to know them, but it's mainly because it's more expensive good, that means people want it less. More cheap good, people want it more. That's the basic idea here. And where they intersect is the equilibrium point. That's the real world price and the real world quantity that's actually being produced. So now we're going to go over consumer surplus and producer surplus. So here's a supply graph, here's a demand graph. This shows the consumer surplus. What does that mean? That means what consumers gain almost by buying the product. This is the maximum price that consumers are willing to pay for a product. This is the demand graph. And then this is the minimum price that suppliers will sell the product. Now this is the price that consumers actually buy it for. So this is the consumer surplus. This is almost what they gain. Producer surplus is almost the same thing. This is what producers are willing to, minimum that they're willing to pay, and this is the maximum and profit that they could make. And then this line here, that shows the amount of profit that they made. So consumer surplus, producer surplus shows what consumers and producers gained by buying that product. Then I've seen occasionally that AP Macro has asked you to calculate consumer and producer surplus. That is really difficult almost sometimes, but it's a basic triangle. Remember, 1/2 base times height. You calculate the base, you calculate the height, and then you multiply by 1/2. Sometimes it's more complicated shapes. However, I'm pretty sure AP Micro has never asked that on the AP exam. So now you can see surplus and shortage. Let's say that the price is high. Let's say it's over here beyond equilibrium. Ignore the equilibrium. That means we're having a surplus. There's a lot of product because if the price is high, people aren't actually buying the product. So there's a lot of the product left. Then if the price is really low, like down here, then we have a shortage because everyone's buying the product and no one's actually selling it. So now we can also see that there's also price floors and price ceilings. Here it's called a rent ceiling, however, same thing, price ceiling. All you need to know is that a price ceiling, for it to be effective, has to be below the equilibrium because then people are buying it for a cheaper price, the maximum ceiling. If a price ceiling is up here, that doesn't change anything. Then a price floor has to be effective if it's above the equilibrium, so above this point right here. Then you can see that there's a deadweight loss. The deadweight loss is basically the inefficiency caused by price ceilings, price floors, or any other inefficient systems. Or different shifts to supply and demand. People generally don't struggle with this, but it's good practice. So go over these questions and pause the video. Now that you've gone over these questions, hopefully, let's go over them. First, a new grilling technology cuts production times in half. This increases supply. So that means price decreases, quantity increases. Here we go. Then the price of chicken sandwiches, the substitute increases. So if a substitute increases, so like your competitor almost, that means more people are going to buy you. so the demand increases. Then this one tricks a few people. The price of hamburgers falls from $3 to $1. Assuming the product is a hamburger, that doesn't change anything, because that doesn't shift the curve. If it goes from $3 to $1, it goes from like here to all the way down here. You get what I mean? It changes the equilibrium, but it doesn't actually change the curve. So it causes a shortage, but it doesn't really cause any change to supply and demand. Now we're going to go over cost curves and the production function. You might be like, what is this graph? Well, this kind of shows the law of diminishing marginal returns. The idea where there's an ideal amount of workers you want. Let's say that you're running a taco truck, right? Having one person, yeah, that's fine, but you could be more productive. 2, 3 people, that's pretty good. But then let's say you keep hiring people, you keep hiring people, then you got like 10, 15 people in your taco truck. The taco truck is just so full, you can't really be that productive. So it starts to decrease. That's the ideal law of diminishing marginal returns. That overall, there is a decreasing point, and there's an ideal amount of employees or workers that you want at some point. So here's the main graphs. This one shows the amount of total product you can make. So there's 3 main stages. First, it's increasing rapidly. It's really low, but it's increasing rapidly. Second, it's increasing, but it's slowing down. And then third, it's starting to decrease. This graph kind of shows the marginal product of this. Here, the marginal product not only is positive, but it's increasing, which is why it's increasing so rapidly. Here, the marginal product is still positive, so it's increasing like we see here, but the actual curve is decreasing. Then here, it's actually negative, so marginal product is negative and decreasing. Now we're going to go over the cost curve, which at first it might seem absolutely crazy, but it makes sense at least. Remember marginal cost. Same thing with the law of diminishing marginal returns. Marginal cost, there's an ideal amount of workers or ideal amount of quantity you want, and then at some point it starts increasing dramatically. So marginal cost kind of looks like a Nike swoosh. Then average fixed cost. Remember, fixed costs are just the amount of money you have to pay that's fixed. It's simple as that. Let's say you make a business and the fixed cost is $1 million. Well, the higher your quantity is, and the way we calculate average fixed cost is by taking your fixed cost and dividing it by your quantity. So let's say you're at 1 million and your quantity is 1. That means your average fixed cost is 1 million. That's really high, kind of like here. But then let's say your average fixed cost here is 10. That means it's 100,000. So that's really low. Then let's say your average fixed cost was 15. That would be, I would believe, 80,000, something like that. So you can see that overall, the more quantity you have, the lower the AFC is. So it slowly starts to decrease. It never reaches 0, however, it slowly approaches 0. Then you have average total cost and average fixed cost. It kind of makes sense. Average total cost is a combination of average fixed cost and average variable cost. So you add these two up. So overall, the ATC should be above the AVC and AFC. The AVC increases because of the marginal cost. If marginal costs are starting to increase, the variable cost starts to increase as well, as we're seeing here. So if the variable costs start increasing, that means the total costs start increasing. So it's all related. This is the basic cost curve graph. So now let's do a practice problem here. Pause the video and try to answer this. The fixed cost here is $50. Based on the cost and output data in the table above, what is the marginal cost when a firm increases its outputs from 3 to 4 units and the average total cost of producing 4 units? So first, let's calculate the average total cost at 4 units. So the variable cost is 90, the fixed cost is 50, 90 plus 50 for your total cost is 140. Your average total cost, 140 divided by 4, your quantity, 140 divided by 4, I believe that's 35. So that narrows the answers down a lot. It can't be A, it can't be D, it can't be E. It's either B or C. So now we have to figure out the marginal cost. For marginal cost, you just subtract. So 90 minus 65, that's the marginal cost, because fixed cost isn't increasing. So 90 minus 65, you got 25, and your answer is C. So now you have the long run average total cost, or the cost curve. This is just the cost curve in a long run situation. This is a short run situation. In the long run, it kind of looks like this. We have economies of scale, where the cost per unit starts decreasing, returns to scale, and then things start going out of hand. It's just like the taco truck situation. There's an ideal amount of workers you want that achieves a constant return that you get, the maximum profit you can get. If you get too many workers, that can be called diseconomies of scale. You're getting too many workers, it becomes too costly. Or if you have too few workers, that's economies of scale. That means you aren't utilizing or maximizing your profits or your productivity right now. So now we have to understand profit maximization and the shutdown rule. Profit maximization is really simple. It's where marginal revenue meets marginal cost. So here, if we look MR equals MC, the magic code almost, MR equals MC right here. Why is this? Because if you increase from here, well, costs are now above marginal revenue, so that means it's more costly to produce. That's not good. Then let's say here, well, you can have more marginal revenue. Why aren't you producing more? So it's exactly where MR equals MC for profit maximization. Then we have the shutdown rule. It's a rule where it says that a firm should continue to produce as long as the price is above average variable cost. If price is below AVC, then they should shut down. So for this graph, we have the marginal cost curve, AVC, average total cost or AC, and here at the 0 point profit point, that's AC and it intersects MC. So what does that mean? That means you're making no profit. When average total cost meets marginal cost, that means you've hit your maximum profit. Your 0 profit point. The shutdown point is when that price is below AVC. So this is a shutdown point. All of this is a shutdown zone almost, where the cost is too cheap, where they're not making enough profit to actually meet up with the cost, so to speak. So now let's talk about our market structures. There's 4 main market structures. We learned 3 of them have graphs that we're going to cover. First is perfect competition. Remember, perfect competition is the ideal situation. It's what we want to actually have. So in the industry, so this is the total country, the total industry that's going on. It's a basic supply and demand graph right here. Supply, demand, boom, bam, shazam. But the difference is the firm. So this is where things can get a bit weird. Marginal cost is just like we learned before. It's a Nike swoosh. It's the diminishing marginal returns. Average cost, just like before, just like this. And then average fixed cost is a decreasing line, what we learned before. But what a lot of students don't understand is this curve right here. Demand equals marginal revenue. What does that mean? That means that the demand curve is a flat line. Why is that? Because in perfect competition, there's a lot of different competitors, hundreds, thousands of competitors. So the demand is really, really low. Let's say that you have a price let's say that currently the price in the industry is $10. Well, that means they're only going to buy your product at $10. If you increase your price to $11, let's say, no one's going to buy your product because of the substitution effect. People are going to buy other industries or other firms. So the demand curve is a flat line, kind of like this. Demand equals marginal revenue for a perfect competition. Now we have monopolies. Monopolies are different as they control the entire industry. They are the industry, basically. One firm controls the entire industry. So here, instead of having a flat line here, demand is a downward sloping line, mainly because they're the only option. If they increase the price, other people, consumers, have no option. They have to buy from the monopoly. So it's a downward sloping line just like this. A key characteristic here, marginal revenue is right here. It's reduced from the demand line. That's really important. Marginal revenue is below demand. Make sure you remember that. Then marginal cost, like before this, average total cost, just like here. The way you calculate the profit maximization point, MR equals MC, but you go all the way up to the demand line. So here is where you're making profit. Here is where you pay your expenses because of the cost. This is all your profit. This is the deadweight loss. This is what is lost due to inefficiency of monopolies. Then monopolistic competition, at least on the graph, is very similar to monopoly. Demand Marginal revenue is below demand, marginal cost, average total cost. The difference here is that a monopolistic competition eventually becomes perfect competition. Why is this? Because monopolistic competition is kind of in between a monopoly and perfect competition. Monopoly, there's one firm. Perfect competition, there's thousands. Monopolistic competition's in between. So because of that, they start off kind of like a monopoly. They make a huge amount of profits. They have deadweight loss. But then eventually they start to see, oh, costs start to increase. That causes a problem because marginal revenue starts to decrease. And then boom, they make no profit. So overall, it's the exact same graph. And this can help you kind of understand what's going on here. On this graph, demand equals marginal revenue. So if you increase your price just a little bit, no one's going to buy your product because there's a lot of different competitors. Monopolistic competition and a monopoly are relatively the same. Oligopoly, there's a whole lot of things that can happen because there's different situations that can occur. Now we can talk about the factor market. The factor market is basically the graphs that show labor demand and labor supply. What is going to fuel all these different companies. So on the y-axis, we have the wage. This is almost like the price level from before. The wage, what we're going to pay workers. And then x is the quantity of labor. Just like before, there's a positive sloping supply graph and a negative sloping demand graph. And then, just like perfect competition, a regular firm, it's a little different, however, it's very similar. Demand equals marginal revenue product, which is basically your marginal revenue. Same thing here. Supply equals marginal revenue cost, which is the same thing as a marginal cost. And this is it here. So you can see supply is a stagnant line, just like perfect competition, demand is a stagnant line. Why is this? Because if you're going to offer a lower wage, let's say you're McDonald's and you offer a $6 wage, why would anyone work for you? They could just go to another job, get like $10, $11 an hour wage. It doesn't make sense. So it's a stagnant line here where there's a bare minimum they're willing to accept. That demand is a downward sloping line. Then this is the same thing as supply and demand, but remember minimum wage. Minimum wage almost works like a price floor. We can see that there's going to be a surplus of workers if you have a minimum wage because you're getting paid more than the equilibrium, so there's more workers, but there's not enough jobs to actually fill all of those workers. So now here's a side-by-side graph. Supply, demand, and then the firm, it's a downward sloping line, just like what we saw before. And same profit maximization rule. Marginal revenue product equals marginal revenue cost. Same thing here. Now here's a monopsony graph. What a monopsony is basically a monopoly that only hires, that's the only employer in the industry. So here, very simple graph. Demand is downward sloping. You have marginal revenue cost, and then supply is just below the marginal revenue cost curve. Very similar to a monopoly graph, where marginal revenue is below demand. Here, supply is lower than the marginal revenue cost. Very similar. Now we can talk about externalities. Every decision you have, every action, policy, they have benefits and costs, and we can graph those benefits and costs right here. This is the externalities graph. Here is a marginal benefit, a downward sloping curve. On here, we have an upward sloping marginal cost curve, and then we have equilibrium here. This is price, and this is this is quantity. Then you can have negative and positive externalities. A negative externality means that there's more cost than benefits. So here you can see that the marginal social cost is above the marginal social benefits. And then the marginal private cost is right here. So this is the total harm that is going on. Same thing you can apply to marginal benefits. Here's a positive externality, and you can calculate the same thing, the difference here. So that's the overall benefits you see. Finally, we have the Lorenz curve. The Lorenz curve calculates or measures the amount of inequality going on in the world. So here's 3 main lines you want to know. This line means there's perfect equality. That means that 10% of the population, they control 10% of the wealth. 50% of the population, they control 50% of the wealth. 100% of the population, well, they control 100% of the wealth. it makes sense. 1%, 1%, 20%, 20%, etc., etc. Then let's say feasible equality. The perfect equality is very unrealistic. Let's say there's feasible equality. That means that it's kind of like this, almost like a banana. Then actual income distribution of the United States kind of looks like that. The way you calculate the Lorenz curve is the difference between perfect equality and feasible equality. So here, it would be the total area of this area right here, the difference between perfect and feasible. Now, you personally don't have to calculate this, but there will be options for this on the AP exam. So like, for example, it might say 0.5 or 0.75 or something like that shows the area of this Lorenz curve. Now that's everything, at least for AP Micro and their graphs. It's really important, it's very simple. All of these are very simple, but it's important to understand the ideas behind this. Why marginal cost is increasing like this. Why it's like this. Why is marginal revenue stagnant. All of these different things are important to understand at a conceptual level so that you can get a 5, so that you can graph on those free response questions, and so that you can do well in the exam.